Hi everyone, myself Sandeep Kumar and I am from Uttar Pradesh. Currently, I pursuing my bachelor's degree from ABS Engineering College, Ghaziabad. I done an internships in the Emertxe on home automation based on Internet of Things. What we have learned from this Emerging IoT online internships: basic C and C++ programming concept, how to install 3 tools for Windows, Arduino IDE, PiximLab, virtual port installation process and environment setup, basic of IoT and applications, IoT devices and their working, embedded system, how to handle and run hardware like CLCD sensors, implementations of IoT in daily life, working with latest technology, software for microcontroller and automation. Table of content: these are the table of content which I covered in my PPT and we also seen in the IoT internships. C programming started with the very introduction of the C programming, suggested the best IDE for practicing, important characteristics of C language and applications of C language, data types and keywords, categories and C languages, advanced C assignments. Topics covered in C: basic data types, operators, control statement and type of control statement, if else, switch case, for loop, while loop, do while loop, array, functions, pointer, string, storage class and pre-processing. So these are all the topics covered in Emerging IoT. So these are the topics covered in C++. Embedded system: any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Types of embedded system: self-alone, real-time, network, mobile. Components of embedded system: software, actuator, sensor, ADC, human interface, diagnostic port, memory, PGFA, DAC, ADC. Introduction to Internet of Things. The Internet of Things is an ecosystem of connected physical device objects that are accessible through the Internet of Things. IoT is a system of interrelated devices, digital products, objects, people or animals that are provided with unique identifier UID. It has the ability to transfer data over a network without requiring any human interaction. The idea of this blog post is to provide introduction to Internet of Things as well as expose reader with the market potentials, high level architecture and simple explain IoT use cases, beginners to get a practical and real perspective of IoT. Components of Internet of Things: IoT device, IoT gateway, network, cloud. IoT device using sensors gather information from multiple sources. IoT gateway integrate multiple IoT devices and collect data from them. Network centered around internet, all the information is exported to cloud. Cloud, a platform that connect to internet, analyzes the data. Applications of IoT: these are the applications where we can see the IoT working and implemented: industrial, automotive, smartphone, healthcare, retail, logistic, agriculture, education, smart city and environment, energy, network, aerospace. Architecture: first principle, addressing scale, connectivity, data volume, device size, cloud, queues, storage. This is the reference architecture. First, the device is connected to the IoT capable devices. Existing IoT low power devices, this is the power which is coming to the gateway, then IoT solution backend, and then we present in the business connectivity. Like presentation: project agenda: control garden lights on basis of sunlight intensity. Lesser the sunlight, brighter the garden light. Temperature system control: switch heater and cooler on or off remotely, switch heater off automatically if the temperature indoor exceed 35 degrees Celsius. Water tank control: switch inlet and outlet valve on or off remotely, switch inlet valve off automatically if the tank fill up, switch inlet valve on automatically if the volume of tank drop below 2000 liters. Project implementation: garden lights, LDR sensor, temperature system, LM35 sensor, water tank, serial communication protocol, microcontroller, ATmega 382P on Arduino Uno board, coding Arduino IDE, internet connectivity, Ethernet Shield W5500, mobile applications for remote control Bing IoT app using PiximLab. Garden lights, ADC, light dependent resistors LDR used to sense light and send analog signals to microcontroller. Microcontroller adjust brightness of garden light with respect to analog signal sent. ADC used to analog input only. Analog pins A0 to A5 connected to ADC block. Arduino IDE, the Arduino Integrated Development Environment or Arduino Software IDE, contain a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions, and a series of menus. It connects to the Arduino hardware to upload the program. Temperature system: LM35 sensor, an increase of 0.01 volt for every 1 degree Celsius rise in temperature, hence analog input divided by 0.01 to get temperature of room. This temperature is then displayed on CLCD controlling heater and cooler remotely. Blink mobile IoT app using ETH W5500 Ethernet Shield. Arduino Uno is connected to the internet. Firmware configuration provided by the Blink is used to connect to the Blink cloud. Blink mobile app is used on the user end to connect to the microcontroller through the cloud. Data streams are created on Blink dashboard templates. These act like virtual phones for exchange of data between mobile app and microcontroller. Water tank serial communication. Serial remote tank simulator used. Null emulator used to set up serial communication between PiximLab and serial tank. COM6 to COM7 in real world. RX pin of tank is connected to TX pin of and TX pin of tank connected to RX pin of microcontroller to control inlet valve or outlet valve. Send a byte either 0x00 or 0x01 respectively, followed by another byte 0x01 to enable 0x00 to disable. Serial write 0x function used for transmission of 1 byte at a time. 0x30 byte is sent to request data from the volume sensor. It sends volume in 8-bit serial dot read used to read those bits. Blink app virtual pin V3 used for displaying volume on mobile app interface in gauge form. V4 V5 data stream used for transfer of data related to on or off status of inlet and outlet valves. V7 PI used to send notifications to terminal on app corresponding which is created on developer mode in the app. The microcontroller is so programmed as to turn off the inlet valve if the tank is filled up and turn on the inlet valve if the volume of tank drop below 2000 liter. Automatically it sends corresponding notifications regarding these events on the app to real-time volume of water and on or off status of inlet and outlet valve is displayed on the CLCD. Now let's get into our project. This is LDR with high resistance and this is LED. Now it's glowing and during when we load that resistance the LED is reduces the light and stop glowing. Now you can see that the LDR are off which resembles daytime. When we increase the resistance the LED start glowing again. So this is the first project. Next we see about the cooling and heating system. This is a Blink application we are using for on and off the heater and cooler. There is a CLCD where we shows the temperature and cooler on and off. Now we gonna on the heater and we see in CLCD it shows the heater on notification. Now we want to slowly increasing the temperature to 32 to 35 Celsius. So when we reaches to 35 degree, the heater automatically cut off, and it shows the heater off notifications in CLCD, and it is also shows the notifications in the blink and temperature if it is greater than 35 degrees Celsius. Now then we switch on the cooler, which slowly reduces the temperature to 27.9 degrees Celsius. It automatically cut off the cooler, and it shows the notifications temperature is greater than 35 degrees Celsius, turning off the heater. Temperature is normal, turn off the cooler. It shows like then this is a heater cooler. Now the second project, next we see about the tank serial communication, and wait a minute. Yeah, this is the tank serial remote tank. It contains 33,000 liters of water. It connected with the COM1, and then means return. It slowly reduces the tank, which can switch on. Going to switch on it using a blink app. When we reaches the 3000, it currently off the outlet. When we reaches the 3000, we will see that yes, say volume shown in CLCD. When it reaches the 1500, it automatically cut off the outlet and start inlet the water, and it shows the notifications water level is less than 1500. And it automatically cut off the outlet and start inlet the water, and it shows the notifications water level is less than 1500. Water inflow enabled, so that no tank is increasing the water, raising the water by filling it up. Let's wait a minute. So that no tank is increasing the water, raising the water by filling it up to, then it cut off the outlet simultaneously. Now it's increasing slow by slowly. When it reaches 3000, it automatically cut off the inlet of the water. We will see that. Yeah, now it reaches 3000. Now it's automatically cut off, and it shows the notifications is less than 1500, and it is greater than, and it is closer, and it is closer to 3000 and disabled. So this is what a Emertxe IoT internship on home automation based on Internet of Things. Thank you.